Douglas Richardson. Do you have something on here? You do. You set up Doug's stuff. So I'm going to introduce Doug briefly because I think of the people in this sort of geospatial field. I don't know anyone who has a broader perspective on everything that's going on. He began with a company of his own, Geo Research, that applied GIS technology and spatial analysis, eventually sold. Became the executive director of the Association of American Geographers, which he is still. He turned a very large association around from the red into the black. And his interests have gone from the technology side of the geospatial to the geohumanities and even neogeography. Although I don't think you're a neogeographer at heart, perhaps.
I don't use the term.
Okay, he doesn't use the term. But he's also been tremendously helpful to us here at Harvard when we began the Center for Geographic Analysis. He came up to Cambridge with various presidents of the Association of American Geographers in tow to give us advice, and so we're truly grateful that he's here with us today. Thank you. And you probably should leave that out.
Okay. Thanks so much, Peter. It's a great pleasure to be here with you. I know I stand between you and the reception, so I'm going to speed this up a little bit and abridge my comments. But I wanted to just take a few moments and focus on, I know this conference is focused primarily on policy, but I want to focus for just a few minutes on research. And that's to illustrate how research can have a bearing on policy and also to indicate the complexity of dealing with locational privacy and confidentiality in different domains and in different contexts. We have to realize that people inhabit many different contexts, many different domains, and that as far as a cookie-cutter approach to privacy and confidentiality, it doesn't exist. It really is a function of many different factors. So if we take a look for the moment at the question of what is the National Science Foundation and National Institute of Health thinking about now in terms of data confidentiality when research is being done? This is an area that probably, like most of you, has been a major concern of mine since I was a kid, but it's now comes into play because the work that we've been doing with NIH, which is kind of exciting, has raised these issues, and then we've been asked by National Science Foundation to address what are the unique confidentiality characteristics of geospatial data. How does it different from other kinds of data? Why is geospatial data different, and how can we deal with it? For example, most data that you deal with in the social sciences, or even typically sometimes in the natural sciences, when you visualize that data, you visualize it as a graph or as a chart or as a histogram, something of that sort. It's all automatically aggregated, and a lot of its detail and locational and knowledge is scanned. But when you visualize geospatial data, the primary visualization is a map, and that map has patterns that are recognizable to most human beings. If you make a map of someplace in Boston, even I, who've not lived here for a long time, will be able to pick up pretty much where that is. So the visualization of the data is very significant difference among many others. So we've developed a project with NIH on geospatial frontiers in health and social environments. And as we've gone through that, we looked at a number of major, very exciting research areas that are happening right now. It's just such an exciting field. And oddly enough, the health field, the health research field, is not nearly as advanced as a domain than most others. It has not been as penetrated as thoroughly by GIS and geospatial data as, say, transportation, environmental science, and so many others. And if you look at all of the work that's being done on gene-environment interactions, for example, most of that, NIH has now developed really very detailed and sophisticated information about genetic causes of disease. So they can now identify a particular gene, the presence of which or the absence of which means you will have a particular condition. However, that's rarely determinative. It's not determinative, it is probabilistic. So for example, you might have a 60% chance of getting a condition or a disease if you have or don't have that gene. So what is missing is what are the environmental interactions that cause those 40% not to have that gene, or those 60% or not to have that disease or condition, or that 60% to get it. Once we can understand that, then we can begin to make meaningful decisions about the people who have this genetic marker. And we can perhaps help them avoid that. Well, with GIS, we can now develop environmental information which is at a level of sophistication and detail that the genetic information is now. So there's been a big counter demand in health to help understand why these genes express themselves in some environments but not in others. And you can't do that unless you get to almost the individual level of exposure. And so you take an exposure analysis, for example. This is being done now with GPS GIS, real-time GPS GIS, and tracking individual people and their individual exposures, which is a massive step forward in trying to really understand exposures and their relationship to disease and health. Because before you used it was counties or zip codes or something like that, and then you imagine the range. And it was also assumed that all of your exposure occurred where you lived. If your house was in a particular county or zip code, that's what your exposure was. Of course, we all move around. We have sequential places of residence, and we go to work, we travel in different circles. So now we're starting to really have the capacity of getting this kind of very detailed exposure data, which also means that you can track these people on their daily pathways and so forth. So you can imagine in health research, again, there's the confidentiality and privacy issue that type of research involves. We've been working with NIDA, Nora Volkoff and others on a book called Geography and Drug Addiction that Yonette Thomas and I and a few others edited. And of course, when you're dealing with research at this level of detail with drug abuse and drug addiction, you're necessarily dealing with issues of individual privacy and so forth. So all of these kinds of examples that we've been working on in this project, we're trying to put research in these types of categories into a larger infrastructure for NIH. So in this area, we're looking really at spatial temporal analysis for health research. How can you do that and still have patient subject protection? And this is the goal, and the incidental obstacle is privacy and confidentiality. Every time we go down that path for geospatial work in health, you bump into the wall of confidentiality. How are we going to protect this patient's privacy? The same thing about enabling a national geospatial infrastructure for health research, which we're trying to do. We're working closely with NIH on this project. Same thing. When you get this infrastructure, you start compiling all this data. As we know, you compare different data sets, and suddenly things become known that are not otherwise known. And we have a workshop in June where we're trying to put these two massive infrastructure approaches together and come up with a research agenda around these topics. This grew out of what was called the AG initiative for an NIH-wide GIS infrastructure, which we developed about 5 years ago. And that also resulted in a number of workshops and reports. Again, really looking at the tremendous opportunity that this kind of NIH-wide geospatial infrastructure would have. Imagine having all this data available from each of these projects and each of these individual institutes. There are about 30-odd institutes at the NIH. Each one has very tentative and duplicative GIS programs going on. It's really not, despite the fact that health researchers are very intelligent people and good with statistics, they just haven't glommed onto spatial analysis. The gold standard in most health research has been temporal analysis, the longitudinal study. And so now it's beginning to dawn on people that there's this rich and analytical capacity in spatial analysis for health as there is in temporal analysis. And suddenly the floodgates are starting to open. We've been knocking on those doors for about 8 years, and now they're being flung wide open. A report came out of that, which is on our website, Establishing NIH-Wide Geospatial Infrastructure for Medical Research, Opportunities, Challenges, and Next Steps. And to some extent, some of that work has been summarized in a recent Science article, co-authored by a couple of institute directors at NIH. And so now we've got this issue. So we posed this question to NSF, and it's a perennial issue, of course, in health, but it's been dealt with very narrowly, pretty much from a social science perspective. And we recently received another grant from NSF called Addressing Challenges for Geospatial Data Intensive Research Communities. That's what we are here in the room. Unique confidentiality risks in geospatial data sharing within a virtual data enclave. So we're looking at what are the unique confidentiality characteristics of geospatial data. How does it differentiate itself from other kinds of data? And we're looking at what are the scale of risks with those unique qualities. We're also looking at the need for geospatial data sharing. In research, you've got to be able to share data. You've got to be able to replicate an experiment. You've got to be able to replicate research if you're going to have science. So how can you replicate research if you can't share the data? And right now, the only way that happens with the large studies that maybe you're familiar with, like LA Fans and others, is you have to go to a little cinder block building somewhere in Bethesda, strip practically naked, and then go in there and come back out with nothing else on. And it's a very difficult, time-consuming, very inefficient process that does not allow efficient or very widespread sharing of research data. We've got to learn how to share that data. Also, for those of you who do NSF work, about a year and a half ago, they instituted a new policy. Every research project at NSF has to have a data management plan. That data management plan says, how are you going to handle the data? How are you going to handle confidentiality? How are you going to distribute the data and get it out to people, which is also a goal that conflicts with the confidentiality needs. So when those proposals are reviewed, and many of you sat on review panels, typically they have absolutely no idea how to assess a data management plan about geospatial data, because they don't understand geolocation. They don't understand what it means. What are the important aspects of handling this kind of data? So again, there's a need there, and one of the issues we're trying to address in this project is guidance for the data management plans as well. So we all know, and we've heard that research that uses large amounts of data, georeferenced data, is spreading willy-nilly across almost all scientific domains, and several trends are driving this: the massive quantities of data from GPS-enabled devices, sensors, location-aware technologies, advances in web services, cyber infrastructure, new geoprocessing tools for analyzing, exploring, and visualizing large multi-scale spatio-temporal data sets. We also know that these trends are growing. They've got lots of potential. However, these data are highly identifiable, and that the potential opportunities and benefits of collaboration are being constrained by the need to protect these subjects' privacy and confidentiality. We got Myron Gutman, who's head of SBE, saying that the danger of public release of information is made more complicated by the rapid increase in computing power, etc. In all of this real-time interactive GPS GIS data, which is now exploding because that functionality before was only in larger devices. It's been around for about 20 years. But real-time interactive GPS GIS functionality is now in cell phones, consumer devices, navigational devices, and so forth. It's spreading very, very much all around the world. And whose fault is this? Well, as I said, I've been worried about this since I was a little kid. But we developed some of the first GPS GIS technologies and patented those about 20 years ago. And it's this kind of core real-time interactive GPS GIS, which is this functionality, which is now embedded with sensors and attribute information and location and time into very increasingly small devices that are increasingly ubiquitous. So there are, however, ways of approaching protecting privacy with geographic data, and these are familiar to all of you. One of them is through a more elaborate and strict government regulation, which I don't think any of us really are excited about. But I would say I think that you're going to see, despite the sort of lack of concern by many people, I do think that in different social contexts, those issues become pretty significant. Also, there are human subject protection procedures, which really are still grappling with how to come to grips with this kind of information. And those of us who've been involved in the field for a long time, and ever since we started doing GPS GIS, people have been talking about privacy and location for 25 years. I've been dealing with it, and I think for about 20 of those years, the temptation was just not to deal with it, because we were concerned about how it would be dealt with, and it might be dealt with in ways that would really impede all of the potential beneficial uses of that wonderful kind of technology. But at the same time, I think that I see a trend toward greater interest in doing something. We have to work, as a knowledgeable community, I think we have to work with policymakers to make sure that when that happens, when that regulatory activity happens, it's done in a kind of intelligent way that's just narrowly focused on the abuses, but does not bring about problems in other realms. And then there are also several other methods called geographic masking and so forth. And in this project that we're doing with virtual data environments, we're looking at an awful lot of that. And masking, as you know, there are many different ways to do it. I'm going to skip through these slides. But there are many examples, aggregation, transformations, randomization, perturbations of the data, et cetera. And we're looking at all of these in very great depth as mechanisms to use for masking the data. However, masking data also has a trade-off. The increasing the amount of error introduced affects the results of spatial analysis performed on masked data. It's essentially it's bad medicine. It's like taking mercury in order to cure yourself from whatever it used to cure you from. I guess venereal disease or something. So it's got a cost. If you can mask it, and that does solve one problem, but it creates another problem in terms of analysis. And this the approach that we're looking at now is working with University of Michigan on developing a geospatial virtual data enclave. And this method would be designed to help researchers develop and implement procedures for accessing and sharing georeferenced data, research data, in ways that offer adequate protection of geoprivacy. So part of the idea here is that you go into this, you can actually work on the real data that was gathered, you can work on the secure data, you can use it to build upon that research, you can use it to try to replicate that research, et cetera. And main component of this, the VDE take place on a server in a secure data center, and we've got a lot of methods in place that people at University of Michigan have been working on for quite a while. We're working there with the Inter-University Consortium for Political and Social Research, ICPSR. There's absolutely no way to pronounce that acronym, by the way. Anybody can. But we're working with George Alter there. Formerly, I was working with Myron Gutman on these kind of projects, including a digital social science library. So we worked with ICPSR for quite a while, and we think that we have worked out a formula that will be successful in allowing this data to be shared among researchers from Harvard and everywhere else in a fairly convenient way. There are lots of issues, both policy-wise and technical, that have to be worked out, and that's what we're working on. So specifically, these are some of the things that we're working on. I could get into great detail, but given the time, I think I'll wrap it up, and we have a reception following this. But the point, the overall point I'm trying to make is that research is a big part of what we do, and research is really being impeded by what one consider either legitimate or not legitimate confidentiality issues. But particularly when you're looking at health research, when you're looking at most of the kind of research that's funded by NSF, there are human subject protection provisions, and I think that we have to be careful as those evolve that they don't evolve into some kind of overreaching fashion that could really crimp research and really crimp data collection. At the same time, if we don't do things like this and we don't work out methods for sharing that data, we will find ourselves in those kinds of situations. So We need to take seriously the proposed legislation, work with it to make sure it doesn't go too far, but at the same time come up with technical and regulatory methods that that function only to curb the abuses and not the benefits of what we do. Thank you very much.
Let's take a question or two. Or you can head out and, yes, we'll get to the mic right away.
Thank you. I just wanted to, I guess, sort of pose a thought just from the discussions today, and this is coming from, I actually work in the United Nations, so thinking a bit more global around geospatial information, but also around how governments might be dealing with these policy and legal challenges. And so what we've seen today is, I think it's kind of like two threads. On one hand, we can see out there in the community, whether it be the private sector, NGOs, other organisations, that are developing tools, applications, data, information, like we've seen in the last few sessions, where it's very, very proactive and moving ahead at a pace, but not so much being conservative about how it deals with privacy and confidentiality. Whereas what you've just been talking about now is how governments tend to, particularly in some of these mainstream areas with private data, whether it be health, social services, etc., is how they deal with that, and it's a lot more conservative in terms of the privacy and confidentiality. And I guess what I've been, one thing that we sort of struggle, not only just thinking about, say, the US, but other nations around the world, and how that works in a global economy, but how we bring those threads together, how on one hand you see fantastic work happening in that community of open data, VGI, crowdsourcing, etc., versus what's the traditional authoritarian approach to how you structure your policy and your governance around mapping. And I guess what I'm trying to allude to at the end of the day, and I can recite many, many examples from my own experiences, is that at the end of the day, when decisions have to be made around the evidence base and policy and governance and the people, governments tend to have to make decisions based on authoritative information. And we see that typically even now in disasters. The Japan earthquake was a really good one where a lot of information is made available, but government data was used at the end of the day. In my own case in Australia, with 3 years of floods, government data was used for the decision making at the end of the day. And part of the trick is, and someone mentioned addressing, street addressing earlier, is how you tie into this fundamental underpinning information of countries and actually bring that to bear in a much more effective and efficient way. It's not an easy one, but I just thought I'd pose that question. Thank you.
Well, that's a related question. You're talking about authoritative data, so-called, as opposed to other kinds of data. Well, I serve now on what's called the National Geospatial Data Committee here, which was looking at the NSDI, National Spatial Data Infrastructure in the United States. But we're also looking at the GSDI, which is the Global Spatial Data Infrastructure. And all of those have some core data sets, but they're breaking down because the core data sets are so-called authoritative. Sometimes the accuracies that they represent are no longer the best accuracies that can be received. And essentially, they're also a very small amount of the geospatial data that's now being generated with all of this real-time interactive GPS-GIS data. That's where space-time data comes with, and it also doesn't have temporal dimensions to it. So the data that is really pouring out and exploding is spatial temporal data. Linked, fused spatial temporal data with real-time interactive GPS-GIS. This is whether it's tied in with LiDAR systems or anything else, that's still the basic functionality. And it's producing a whole raft of new integrated spatial and temporal data that is using, very useful, for example, disasters and so forth. So I think that's breaking down, and the concept of authoritative data is based upon someone who has a license who collected it, rather than a scientific approach where you look at QA, QC, in all of the actual qualities of the data itself, and then you gauge whether that data is authoritative or not. So authoritative had been in the past kind of a legal designation, meaning that somebody with a license, but perhaps not a broad sense of the science of the data, collected it. And now I think authoritative is shifting toward sort of scientific analysis of the database itself, QA, the QC, the data completeness, the representativeness, et cetera, the methods used to collect it. So I think that data is very important in countries around the world, but it's sort of being superseded in many ways. It still will be a core set of data, but for most applications, it will be data that's being generated, on an ongoing basis.
Doug, thank you very much.